Dear students, welcome to Sia's digital classes. Today's concept is order statistics. It's very important in this unit. So let us check it out. What is that order statistics? So order statistics, in order statistics we'll consider some variables a1, a2, a3 so on up to an. Some variables represents n, small n, independent and identically distributed variates of cumulative distribution f of a. So what that means, here we are considering some variables like x1, x2, like that we'll consider it. Similarly, in terms of a's we are considering some variables which are extended up to n terms, and then they are independent and identically distributed. What that means? Independent means they are not dependent on one another. One output you got means that's all, the other one is not dependent. So independently they'll approach, and then identical. So if you consider discrete data or if you consider continuous data, both will be same. So independently identically distributed, IID will write, right? In some 2 on we are learning independently identical. So the same thing here, variables also I'm considering in independent identically distributed variates, and which is f of a. It's a distribution f of a we have. Then the rth order statistics of a denoted by AR is given by. So how the order statistics goes on, let us check it out. The formula AR is equal to A of order 1 less than A of order 2 less than A of order 3 less than A of order 4 less than so on up to less than A of order n. Now order n, why I am calling? Because A1 I have written, check it out. It is not just A1, here A1 we have, right? So A1 I am calling as A1 only, but this one A of order 1 I am calling, means order statistics is represented with a sub value within brackets. Now what is that A1 of order 1 means? Like if you want to check topper in the class, how you will check? The highest rank person who are got the highest rank becomes a first ranker, and the next highest will be the second, and next highest will be the third, like that, right? So subtracting highest to the lowest, we will go on subtracting the highest value, so we'll get the least up to the last rank, isn't it? So how to get that one? Like I want to know that exactly how it goes on, means we can utilize order statistics over there. Like car race is going on or bike race is going on, you want to check how average is going on, or which is the highest, which is the lowest car in the race, like that you want to check it out. So there we can implement order statistics. In order will maintain, that is like a least value will come first, then next list next list, like that it will you can go on getting the data. So here A1 becomes the lowest value in like I have some values. Let us take 5 to 3 I have considered. So what is the lowest value here? Least value is 2, right? So 2, 3, 5 becomes a order statistics for us. That is 2 becomes A1, then 3 becomes A2, then 5 becomes A3, like that. So order statistics means arranging in ascending order, increasing order it will go on. So least value becomes a first order value. So A1, A2 so on up to AN I have considered. That is your order statistics. Now what is R and all, what we have considered, that let us check it out. R is equal to 1, 2 so on up to n terms, we know already we considered. So is the order statistics of AR. So representation for rth order statistics AR. So in this way we'll represent AR within the brackets. So within brackets if you represent, that becomes the order statistics. Next, let us check it out, its distribution, how it goes on. So first point, if B1 is equal to A of order 1 represents the smallest order statistics of A1, A2 so on up to AN, then its cumulative distribution function Fn of A is given as. So what we are considering here? First order statistics, that is your smallest one. Just now we discussed, right? Smallest value becomes a first order statics. So B1 I am considering as first order statics, that is A1. So how we can represent in distribution? Let us check it out the formula. So this is a formula F1 of A, because first order statics we are considering. So F1 of A is equal to 1 minus 1 minus f of A to the whole to the power of n, because our function is f of A, and 1 minus we are doing because every time lesser values will go on considering, right? So this becomes a formula for B1, that is your the distribution for the smallest order statistics. Okay. Now let us check it out the second point. If BR is equal to AR, I am considering, that is your rth order statistics. First we have done smallest order statistics, that is the first beginning one. Then rth order statistics, let us check it out how the formula goes on. So again for the same set of data, that is A1, A2, so on up to AN data I am considering. Then its cumulative distribution FR of A is given as FR of A, because rth order statistics we are considering. So FR of A is equal to probability of XA of X we are considering, which goes to the formula of summation J is equal to R to N NCJ. This formula you will get it, like how it is distributed. Let us check it out. Like NCJ we got, that is binomial distribution. Here we are checking it out, like which is the value we are getting, like success out of n values, which is the order statistics we are considering, right? So here we can utilize binomial formula. So out of n number of variables we are considering rth variable or nth variable, whichever we require out of that. So whenever like that, we'll take success or the whichever value, required value we are dragging out of it. So there you can utilize binomial formula. So I am utilizing that formula here. So in terms of NCX it will be, right? So like that we got here also NCJ FA to the power of J, jth term we are considering. So FA to the power of J, 1 minus FA to the power of n minus 1. This is regular order statistics formula, this one. Using that we'll get an increasing order. So this becomes a formula for rth order statistics. So that is your second point. Now let us go for the third one. If Bn is equal to An. Now I am considering Bn is equal to An. An means largest order statistics. It is the highest one. Smallest we checked, rth order we checked. Now highest, whatever data you are considering in that highest order statistics. If you want to know how the formula goes on, let us check it out. Then the cumulative distribution of Fn of A is given as Fn of A is equal to Fa to the power of whole power n. Yes, n terms we have, last highest value we want means definitely to the power of n. If you consider, that becomes a highest value, highest order statistics. So this becomes a formula for highest order, that is the largest order statistics, which we considered as An, Bn as a An. So this is your nth order statistics, rth order statistics, least smallest order statistics. These are all different statistics. Using the formula we can obtain. So this is the concept of order statistics. We can get the order, whichever order statistics we require to the data, smallest in between the second, third, fourth, whatever we require. Using this distribution formula we can obtain our order statistics. So hope you have all understood this order statistics concept. See you all in the next session. Thank you.